Hey, Music 206. This is the second part of my lesson on synthesis and synthesizers. Um, so as you guys know, we the first part we talked about today or this last week, which covered basically from this slide sound oscillators, right? So the idea was understanding the basics of sound synthesis and then really focusing on oscillations and how those are arranged and work in a DAW. Okay, so we're moving on now to filters and amplifiers, or sorry, filters and the amp envelope. So those are the two things I'm going to talk about in this lesson. Um, and then there'll be a short quiz on Blackboard, of course, which will be due again on Friday at the end of the day. Okay, so when we talk about synthesis and synthesizers, almost every synthesizer, as we saw from previous the previous lesson, every synthesizer has a filter of some kind in it. Okay, so when we talk about filters, they generally obviously do what we know they do. They filter out the sound. They filter the frequency band in some way based on certain parameters that are set. Okay, this is a filter. I'm going to use a lot of the retro synth in Logic as this example because it has a lot of good graphical interface that you can see easily, which is useful. All right. So the main parameters in filtering are the first thing, which of course is the filter type. Is it a low pass filter, a high pass filter, or a band pass filter? Or there are other types of filters too, notch filters, comb filters, but these are the three most common by far. And then of course, as we know, the filter cutoff frequency, right? The frequency at which the filter starts to work. The filter slope I'll get into in a minute, but that is basically how dramatic is the cutoff of the frequency at the cutoff frequency. How quickly does it go to nothing? The resonance, which we've talked about a little bit, the filter resonance, or what it also is called the resonant peak, is another common thing. And then the last one is the filter drive, okay, which is the overall dB boost of the signal filtered, which I'll show you in just a second. So let's go through these first. This is RetroSynth again. And obviously here you can see that I have a low pass filter, and it's really important to recognize these acronyms. You often see LPF, which means low pass filter, or HPF, which means high pass filter. In RetroSynth, it just says HP or LP, and then BP for band pass, okay? And you can see the different images that pop up when I choose these different types of filters. And that basically is just showing you what, it's just a very simple graphic representation, okay? The cutoff frequency in RetroSynth here is usually a frequency, but not always. So that's what one of the funny things about the cutoff frequency in RetroSynth is that it's actually a value based between 0 and 1, okay? Which is weird. It's just the way Logic has designed it. Maybe it's some classic reason or something, but most of the time it's a frequency. But let me just show you how that works. So in RetroSynth, the cutoff frequency is right here, and you can see if I go to 0, that means the frequency is cutting off at the beginning. If I go to 1, that means basically the frequency cutoff is at the highest end, so it really doesn't do anything, right? So if I wanted to do 50%, then it would go in the middle, right? So this is a weird arrangement. For most synthesizers, cutoff frequency is based on frequency itself, okay? So first of all, if I go here, this is a perfect example. Here in ES2, which is a monster again, the cutoff frequency, oh, look at that. It's from 0 to 1 also. Interesting. So that one also is from 0 to 1. Let's see. Let's just look through a couple of these. ES1, I imagine, because it's based off of the ES2, is probably also from 0 to 1. Where's the frequency? Or the filter. Oh, this is FM, so it's different. I picked the wrong one. ES1, that's what I want. So here is the cutoff. Oh, it doesn't even give you a value. So that's really interesting. It's just graphic. You're supposed to use your ears basically to tune it. So, anyways, but you often see frequency. I think in alchemy, I don't know. Let's see what alchemy shows. So here's my cutoff. See, now it's frequency. See how you see the frequency band showing? All right. Anyway, so moving on. So yes, the cutoff frequency. The next thing is the cutoff slope. Okay, and the slope again is how quickly the sound is going to nothing, right? How dramatic is this slope? So you can see from here, this is the pull down menu, first of all, in alchemy, or not in alchemy, sorry, in RetroSynth. Oh no, don't tell me my internet just went down. Yes, so as I was saying, these are the different settings here. It's my sister's birthday, by the way. Yes, anyways, these are the different settings in here. The filter cutoff slope is showing you the different values for this line to 0, right? So how dramatically, how quickly is the filter cutting off? And if I go into RetroSynth, what you can see here is that the filter, if I choose 6, the line is way slopier, right? It's kind of a gentle slope to silence. If I choose 24 dB, it's way more dramatic. I don't remember if in my last video I said these names. So these names again too, they're about kind of the algorithms used to for the filter, and they also might reference old school equipment like audio, some old analog like synthesizers. They're modeling synthesizers filtering. That's why they have those names. Obviously, they don't have a lot of meaning, but there they are. So anyway, so that's the slope, and it's also it's just referencing how intense the filtering is, basically. Okay. All right. So going on, let's talk about resonance frequency or resonance and what's called the resonant peak. Okay. The resonant peak is a dB peak added at the frequency cutoff. So the most common arrangement is what you see here, where right before the filter comes on, right before the filter activates, there's a peak at that moment, which causes a very specific sound and kind of enhances the quality of the filtering. So let me show you as an example. If I go into RetroSynth, here's a sound I have. Pretty generic sound. If I add a resonant peak to this, which is right here, if I crank this up, it gets like a kind of a whiny sound at the moment, and it really you really notice it when you change this in time. So listen to this. And that resonant cutoff now is emphasized because of the peak at it, right? Here's it without the peak. Here's with the resonant peak. Okay? So that gives you a sense of what a resonant peak will do, and they're very common in filtering to kind of emphasize that change that you're causing the sound or putting into the sound. And I can do this in alchemy as well, or sorry, let me go over to Serum. I can do it in alchemy as well too. If I turn the filter on here, you can see my resonant is right here, RES, and if I crank this up, it gives me a little peak right there. Gives me a little peak right there at the top, and the more I increase this, the more dramatic it is, right? And that's what the resonant peak does in Serum. So again, resonant peak is just this peak right before the cutoff. Another thing about this picture that I put up here, the reason I put this one is just to show you as well. This is a very common arrangement for seeing filters where you don't see the graphic. All you see is these knobs that say cutoff or resonance and drive or what have you, right? And you have to, it's about listening more. I mean, and that graph doesn't really tell you anything anyways, but you're listening to these sounds, and that's how you're determining how they work. Let's talk about drive now. So filter drive is the overall gain in dB for an entire sound. Okay. So if I amplify a signal inside the filter, this is what happens. So you can see over here my filter drive is 0. So the sound, other than the resonant peak, the sound is at normal volume. If I add drive to it, then it basically just increases the volume of the sound that's unfiltered, right? The sounds that are being let through, in this case, a low pass filter, okay? So that's just showing you what drive does, is it increases the volume of the main sound, okay? So that's it for filtering. Before I go on to amplitude envelope, I want to show you one other thing in alchemy here, or no, in the channel EQ. So remember, in the channel EQ, I can add a low pass filter here if I pull this over like this, and then you can see right down here is the dB. And you can see if I change this, how it changes that slope, right? More graphically, you can see it in action, that a negative 48 decibel slope is pretty intense, and it's like a quick cutoff. And then if I lower this to 6 dB, it's a more gentle slope out, right? And I can do the same thing on the other end. And yeah, so that's the basic concept, but you can do all this filtering in here too. And I can also do things like this where I can create kind of a resonant peak, right? And if I narrow this down with this, what's called the Q, now I have kind of a filter that looks more like has a resonant peak, and then it's a low pass filter, right? Okay, so let's go on to envelopes, which are so important and essential in mixing. Let me close some of these things. I don't know why they're open. So so when we talk about the amplitude envelope, we're talking about the sound, the shape of the sound as it leaves the sequencer, or not the sequencer, the synthesizer, okay? So the shape of the sound means, does the sound start quiet and get louder? Does it grow over time? Is it sustained? Is it sound punchy and short, like a percussion sound, like plucking a guitar? Does it sound like a nice long sustained note on a violin? Those are the things that are all affected by the amplitude envelope, okay? And we have this acronym that we use for the amplitude envelope called ADSR. And you see this all the time in synthesizers, the ADSR. And what it refers to, it's an acronym that refers to the attack, the decay, the sustain, and the release of a synthesizer. So the attack time is the time that it takes a triggered sound to reach full decibels, which is measured in milliseconds, okay? The attack time as well, so when I talk about triggered, I mean like hitting a MIDI note, right? The beginning of a MIDI note, that's the attack time. That's when a note is triggered. The decay time is the time it takes for a triggered sound to reach its sustain level. So the next one is the sustain level, and it's the level, basically a decibel level that the note is held at, okay? And held means how long the note lasts. How long is the MIDI note being held down? How long is the MIDI note in the piano roll, right? That's the sustain level. The last one is the release time. When the note is released, meaning when I lift my hand off the keyboard or the MIDI note ends, how long does it take that sound to reach 0 decibels, okay, when the note is released? So notice one thing that's really important here. All of these, the attack, the decay, and the release are all measurements of milliseconds and time. Sustain is a level of decibel, right? Okay? So these are really important terms though. So let's talk about the actual amp envelope, the shape here. So when we look at the amp envelope, first of all, the time domain is from left to right. And it shows just basically on this graph, that's time. And then the decibel level is the vertical, right? Which is showing you the intensity of the sound. So if we talk first then about the attack time. Attack time is, again, the time it takes for a sound to go from 0 decibels to full volume, right, in milliseconds. The next one is the decay time. How long does it take for that sound to reach its sustained level, which is the next block, right? The next block is sustained level. It's measured in decibels. And then the third block, or the fourth block, sorry, is the release time. When I release the note, how long does it take that sound to reach nothing again? Okay? So, the question then is, how does this translate into sound? Okay? So let's take a listen to, let's go to RetroSynth, which is has a nice little graphic interface here. So you can see here we have the attack, the A, the decay, the D, the S, which is sustain, and the R, which is the release time, okay? Notice that all of these, A, D, and R, are in milliseconds. It says MS at the end of them. The sustain level is a value between 0 and 1, okay? And that's just the way it is, and they've decided the values between 0 and 1. So if I play this note, right now, the attack time for this sound is 40 milliseconds. The decay time is is more than half a second. The sustain level is half the volume. And then the release time is very fast, 38 milliseconds, right? So as soon as I release the key, it'll basically be gone. My filter is also working here. Let me move this up a little bit to make it brighter. Okay, so I can really tailor how this sounds then by changing these values, okay? If I take the release time and crank it way up to, let's do 5,000 milliseconds, which is again 5 seconds. Listen to the sound now. So what's happening is I'm triggering the notes, but they're taking 5 seconds to go to 0 once I release them, right? So they're kind of sustaining through and really connecting together, all right? So, and if I do the same for the attack time, let me put the attack time up here at about 2,000 milliseconds, 2 seconds long. Listen to the sound now. So you have this really beautiful sound now. The sound has been transformed from a pad-like sound, a percussive, really short, punchy sound, into a nice, soft pad, right? If I make this even longer, we get even more sustain. Okay? So it's also common too to have synthesizers where there is no sustain level at all. So if the sustain level is all the way up, all I really have is an attack time and a release, right? If you think about it, if there is no sustain level, then the decay is irrelevant because it's at full volume. So listen to this now. You won't really hear a big difference. It's like on or off basically, but the attack time is fairly short here, 300 milliseconds, and the release time is fairly long, 5,000 milliseconds, okay? So there's actually a really nice, you can also see this, let me make another track. You can see this more directly in Alchemy, which is nice. So let me go to Alchemy here, go to Advanced. This is my main ADSR right here, okay? And if I pick a sound, for instance, like a pad is going to have, I have to pick something more normal. Let me try and find something. Let me go to the browser. Let's go to pads. You know, the word pad means kind of that something is sustained. It lasts a long time. Nice. Let's try something like this. Okay, so let's look at this. So notice when I know the graph looks a little different, but if I hold down the notes, they will hold. Let me try a different one. I'm not really getting the graphs I'm looking for. Let me watch this as I hold this, and let me increase the release time. Watch. So the notes will wait. The sustain level is as long as I hold those notes down. Then they finally release, okay? So just keep that in mind. It really matters in terms of trying to get that, the difference in sound. The notes are held down unless there is no release, no sustain time, then the notes can be instantaneous. It really just depends, okay? So let me go back here. Where am I? Back here. So and just another thing to keep in mind is that these are the different ways that we see ADSR in synthesizers. Most commonly, you see it with little sliders like this. So my attack time is a value, my decay time is a value, my sustain level is a volume value, and then my release time. So but notice it says ADSR behind here. This says ADSR right here, right? This is ES2, it's a little bit different. Here's my retro synth again. So that's pretty simple. But you can see that these values change over time, right? Or, I mean, I don't know what I'm saying. These values are in most synthesizers. If I go, for instance, to, let's not do Serum. Let me show you a couple others. Like if I go to the sampler, right? The sampler also has ADSR right here, okay? See ADSR. There's another ADSR too. We're going to talk about that later. Let's look at one more and then I'll be done here. We go to, not Sculpture. Even Ultrabeat has an ADSR. ESE, this might not have one. It really just depends. Sometimes it's, so this is common too, actually. If you'll notice here in the ESE, which is the ensemble synth, all it has is attack and release. So it's basically saying, there is no decay time. It's on or off, but you can set how fast it comes on and how fast it goes away, right? Okay, anyway, so look on Blackboard. There'll be a quiz about all this for you to go through, and I will also email you this PDF again. This is the same PDF as before. So what I've done is I've just added on to the PDF that I started from Monday. So this will be a big master PDF with this entire lesson about synthesizers and synthesis. And I mean, on Friday, I'll be talking about modulators. So we'll use this as well, and I'll just continue on with it. Okay.